Hello, everyone. Can we hear me? If you can hear me, let me see a hi in the chat. Hi, let me know you can hear me. Let me know you can also see me. All right. I see someone saying I'm the first here. Okay, so hello everyone. Good morning, good afternoon, good evening from wherever you're joining in from. Welcome to the AWS Study Series, Chapter 14. It's been for 13 amazing chapters that we've had. We've been running this for the past weeks now, and today we are here again for Chapter 14. And if you've been following through from the first series up until the 14th series, then you deserve a round of applause. So if you're that person and you're here, please just do all to celebrate yourself in the comment section and know that we are also celebrating you. So welcome to today's series. And today we are going to be learning a lot. But before we go into that, let's know where you're joining in from. Where are you joining in from currently? I see Ovia Robin. I see OX Blix. I see Obasero Kunle from Lagos. If we have more people, let me know where you're joining in from as well. Please keep it coming, because this session is going to be very interactive. You're going to be learning a lot from our speaker. And as you can trust, this is the AWS Cloud Security User Group West Africa, and we are bringing topics to you as it matters for the particular season. And this topic today is also something that is going to be very useful if you're joining in as a cloud enthusiast, a cloud developer, someone who is in the AI space, an AI engineer. This topic is going to be very useful to you. So I'm sure that there is a lot to learn today. So I see Victor Robin is joining in from Lagos. I see OX Blix also joining in from Lagos. So it means we have Lagos people here. Where are others? Abuja, Port Harcourt, Cross River, Akwa Ibom, all parts of Nigeria, Canada, Kenya. Where is everyone? So if you know you have people too who should be here, please do well to share this with them, and they should also join in so they don't miss out on all that will be happening. Because at the end of this session, we're also going to have a question and answer session, and you are likely going to win if you participate and you get the questions right. So you don't want to miss out on that. All right, so very quickly, we are going to be bringing our speaker up. And for today, we are looking at a very wonderful topic, which is retrieval augmented generation on AWS using Amazon Bedrock, OpenSearch, and Amazon S3. And we are going to be learning a lot from our speaker. Amazing. Just before I go on, I see Chisom. She's saying hi, Chisom. I see Cyberpath with Alex. That's Alex from Ghana. Amazing. Good to have everyone here today. So just like I said, we are going to be learning about RAG, right? That's retrieval augmented generation on AWS using some AWS tools such as Amazon Bedrock, OpenSearch, and Amazon S3. And we have a very esteemed speaker in our midst who is going to be showing us around this particular topic. And this speaker is someone who is who is so big in the space. He's so big about community. He has been doing a lot for the community, and he has been part of the leadership of this community. And today he's the one with us. He's saying that she's joining from the cloud. Amazing. All right, me too. I'm in the cloud though. If you can see me, I'm also joining from the cloud as well. So it's good to meet you, Chisom. All right, so I'm just going to be reading our speaker's bio so we get to know who is coming on stage, and we are very much ready to also welcome him. So our speaker is none other than Promise Uche Nwachukwu. He's an accomplished senior consultant in cloud and DevOps engineering, and he specializes in building secure infrastructures for diverse clients. With a robust background in IT consulting, he is dedicated to enhancing clients' operational resilience and safety in an increasingly complex digital landscape. And he's very passionate about leveraging innovative technologies and he excels in designing strategic solutions tailored to meet specific business needs. His collaborative approach reinforces partnerships with stakeholders, ensuring the implementation of best practices and regulatory compliance. And he has a keen understanding of emerging threats and trends, and he is committed to educating clients on security measures that safeguard their assets and foster growth. And he continuously seeks opportunities to expand his expertise and share insights with the broader tech community. And that is what he is doing here with us today. He is here to also share insights with the broader tech community, you and I. So I believe that we are very much ready for our speaker. If we are ready, please do well to to clap. I wanted to say to stand, but it's an online event, so let's do well to just clap as we welcome our speaker, Mr. Promise Uche. So good to have you with us today. How are you doing?
I'm doing great. I'm doing great. I'm doing great. Thank you so much for this wonderful introduction. I
Thank you.
was
Thank
wondering, was that me you were introducing?
Definitely. We are so glad to have you on stage today. Thank you so much.
Thank
We look
you.
forward to learning from you as well.
Thank
Thank
you.
you.
Thank you. Thank you. All right. I guess I would start up with the session. Thank you so much, Anne, for the wonderful introduction. I would say it's been amazing. Will I say leading and being at the back end of affairs in this community for let me say the past 7 to 8 years now, if I'm not mistaken, or yeah, about 2022. We started the community 2022, and this is 2022. So I would say let me say 4 years, right? Really amazing. Working with also awesome individuals around who have been helping to ensure that activities keep going round and round and we are actually functioning. So I want to give kudos to the current leaders of the community as well, Kunle, Chisom, and Imo, and the rest of the team. All right. Today we are looking at a very interesting topic. I say interesting because this is something everyone is beginning to see how important applications like this are, and people need to start. I know most people or some people already have that idea, but some people need to start looking at how do I leverage this within my organizations. I could tell a couple of people have been able to build quite interesting applications leveraging will I say systems like this. But of course, if you don't have an idea or if you're wondering how do I implement systems like this, I think this is the best time to take a good look at it at. And hopefully if you pay attention, you will be able to follow through and you should be able to gain something today. I'll be proceeding to share my screen. Awesome. I'm believing you should be able to see my screen now. Okay, good. So, like I mentioned, we are looking at an interesting topic today, implementing RAG on AWS, right? Using both Bedrock, OpenSearch, and S3, right? Interesting, I must say. But before we look into how do we implement this, I think we should start first with um, understanding all of these features, and then we then look at how do we bring them all together. Right. So, as you know, RAG is simply a short form for retrieval augmented generation, which we would mostly use in, you know, will I say, creating systems or applications where you need customized data in, right? Imagine you're building a system or an application within, you know, your office environment, and you need to be able to provide answers to the questions from users that your models can't give answers to. Specifically, recent or updated changes happening within your organization, or data that is particularly um, confined to your organization, right? This is one particular tool you can embed into applications, websites, which you run internally in your organization. And we'll be looking at how we can combine all of this today. All right. So, what is basically the challenge, right? A lot of the times, the challenge revolves around how do we retrieve data, right? And if you have particularly been following topics around this, you would understand that a lot of the time, traditional search systems um, make use of LLMs to be able to retrieve data in such a way that um, you are able to get information within, say, for instance, a defined application which you've configured. But then again, remember that um, the level of correctness or quality of the data which you would be getting from these LLMs are usually tied to what year these models were trained to, or restricted to what year these models were trained to. Say, for instance, you're trying to get a more updated information, your LLMs are not, in quotes, connected to the internet. And then you're asking a question that would require a more recent or updated data. Following the traditional means of data retrieval, you would probably be stuck in the loop there because your LLM, for instance, may not have that updated information provided for you, right? So these were some of the challenges we have faced um, back in the day, or I would say few months, few years ago, looking at the traditional way of retrieving data. Now, LLMs, of course, hit a knowledge ceiling in the fact that the the knowledge the LLMs have are restricted to the dates which they were trained, right? They can't access private, proprietary, or real-time data without external grounding mechanism, right? Without connecting them to tools that would require them access to current or updated information. Now, this is where the retrieval augmented generation comes in to bridge the gap, right? That these LLMs have faced for years, right? The retriever augmented generation grounds, it helps to ground the models, providing them with real time private data combined with reasoning power of the LLMs with the accuracy of your own knowledge base, right? So you can see that we are looking at let me just say about three or four things coming together here. One, your retrieval augmented system um, provides now real time private data. Your LLM has the reasoning power to be able to understand the data which you are providing it with, and gives quality information back to you based on this knowledge is able to get from, for instance, knowledge bases which you have added as a tool to the LLM. So this is how RAG has helped us to bridge that gap with the traditional LLM um, um, issues that the traditional data retrieval systems have had making use of LLMs in the past. Um, I would say the RAG architecture, right? In here, you can see us looking at three basic components. One is the Amazon S3 bucket. Two is what? Your Amazon OpenSearch service. And three is your Amazon Bedrock, right? And as you can see, the Amazon S3 bucket serves as a central knowledge repository where we store all of the, for instance, documents or files, right, that we want to use as a form to ground our LLMs, right? And the Amazon OpenSearch service serves as the intelligent, or yeah, the intelligent vector database, right? It indexes these documents, embeds them, and helps execute them faster, right? And due to the fact that it's indexed all of these documents, you can search across keywords, in a very fast rate, right? It's able to search across all the the keywords provided in your files, right? And it does this at a very fast rate. And of course the Amazon Bedrock, which provides you can call it, say, API accessible foundation model orchestration, or generally look at it as that feature or that platform that helps us to host our models, right? For instance, Bedrock handles embedding generation, query transformation, and final response generation at scale, right? So you can see the specific uses of each of these applications, or I would say features in AWS, and how they are actually coming together to give us a, I would call it, a modern day or a very fast retrieval augmentation generation application system, right? So with Amazon Bedrock hosting the model, the S3 buckets holding all of the necessary files which we need, right? Or which provides us with a more refined, customized um, company focused data, right? And of course, the Amazon OpenSearch, which serves as that intelligent vector database. Now, looking at how all of these features in AWS come together, right? We can see here we are looking at the process flow, right, of the knowledge ingestion. So you can see the documents are stored in S3, right? Then you extract and normalize your text, right? And do what we call vector embeddings, making use of the open search service, right? And of course, the Amazon Bedrock hosting the model. So if you look at the diagram we have here, you will see here as the data source is the S3 bucket, right? The open search service, which is acting as this intelligent layer, right? And then Of course, it provides a vector database that helps to chunk all of the data gotten from the files, right? Now, when a user, for instance, gives a prompt, right, the LLM hosted in the Amazon Bedrock, in this case, right, tries to retrieve the data. So it talks to the vector database, sees what's in there, and then tries to retrieve the data from the vector database and searches all of the keywords which have been um, populated across the various chunks using the OpenSearch service, right? And of course, the data which were populated in the S3 bucket helped in this process. So you can see it talks to the vector DB here, and then from the vector DB, well, LLM gets the context with its reasoning power and then provides you what with a response. So this is just a flow of the process that happens when a user makes a prompt, how the prompt goes to the LLM talks to the vector DB, back to the LLM, and the LLM forwards the answer back to the user. um, just the same way we spoke about how the open search service is helping us to vectorize or create chunks of this data, right, and make them easily searchable across the environment, right? Um, Once the documents are embedded, the vector itself must be indexed for fast and semantic retrieval. So you can see how the open search service itself is providing a powerful scalable vector store with built-in what ML capabilities, right? So you see, it says here vectors are stored within the open search collection using a KNN, well, K nearest neighbors index. This enables sub millisecond similarity searches across millions of vectors, right? So here we were looking at why open search serverless, the fact that no cluster provision or maintenance is needed, automatic scaling of the compute and storage, built-in LL common plugs in, and native support for semantic search over keyword matching. Well, this is the query orchestration here. A user, you know, gives a query or a prompt. The query is embedded, goes to the through the LLM, tries to query the vector DB to retrieve the data. Data reforms, returns back to the LLM, and the LLM pushes the answer generated to the user. You can see here it says the retrieved text chunks are injected directly into the LLM's prompt context window, grounding the model's response in verified up-to-date information from your knowledge base, right? So this just generally explains the flow from the user query up onto the point where the user actually gets his data back. Well, so you can see here integrating DeepSeek R1, right? DeepSeek R1 itself is a powerful reasoning model available in Amazon Bedrock, right? So now integrating it with OpenSearch creates a tightly coupled retrieval and generation pipeline, right? So in our demo, we are going to be seeing how do we actually deploy this, right? How do we deploy this and how do we make it work? Securing the pipeline. Basically, this is just talking about the dedicated IAM roles which the Bedrock uses for invocation of the models, while configuring an IAM role for the OpenSearch signing and the resource level policies on S3 bucket to restrict which document can be ingested, right? And you can see here it says OpenSearch access control. Map backend IAM roles to OpenSearch internal users via role mapping in OpenSearch dashboard, right? This enables granular index level permissions, field level security for sensitive metadata, auto audit logging for all ML connector calls, and least privilege connector configurations, right? And it says always validate IAM policies using the IAM policy simulator before deploying to production, right? So we are going to be seeing how this works, right? And how do we actually implement this? Now, putting it all together, we are looking at here the user request, of course, natural language query submitted, down to Bedrock transforms query into vector retrieval. The OpenSearch finds relevant chunk of the data, augments context injected into prompt, and for the generate side, we see the DeepSeek R1 produces what? Grounded answer, right? AWS handles the Bedrock auto skills inference, OpenSearch serverless adjust capacity, and S3 scales infinitely, while your team focuses on what? The application logic and not the infrastructure. Wow, unlock your data's potential. Of course, the era of static search is over, right? With RAG on AWS, your S3 bucket becomes dynamic, conversational knowledge bases that answer questions, not just what? Return documents. So this is basically saying RAG on AWS is not just a technology pattern, but what it is a strategic capability that transforms your organizational data into what? A competitive advantage through intelligent, secure, and what? Scalable AI. All right, I'm done with um my discussion. I think it's time for us to go into um the demo session. Let me open my demo screen. Let me open my demo screen. Yeah, so I will push this here. I believe we should all see this. I believe you can all see my screen. All right, so um, we will be following a guideline to be able to set this up, right? And this is a sample guideline we'll be making use of to set this up. I'm definitely going to share this on the chat, right? So that anyone who is interested in having this set up in the environment is able to work with this, and of course, have that personal knowledge for yourself, right? So if you look at this, first things first that you need to do, right? It says this tutorial shows you how to implement retrieval augmented generation using Amazon Search Open Service and the DeepSeek R1 model, right? So it says if you're using a self-managed Open Search instead of Amazon Open Search Service, create a connector to the DeepSeek R1 model using the blueprints, right? For more information about creating a connector, you can see this, right? See connectors. Just in that case, we can actually take a look at this. So generally, these are like various ways which you can create a connector from your model to open search service, right? So you can see, yeah, you can see you can create a standalone connector. This sends a request to this endpoint and provides all parameters described in the connector blueprint. So you can see here, OpenAI chat connector, the connector to a public Open AI model service for GPT 3.5. Right. So you can see this. Also, you can create a connector for a specific model. Well, if you want to do that, what else? What else? What else? Also, you can see this is an open AI chat connector, and for also Amazon Sage Maker connector. So those are the various connectors you can create, and of course the codes or the code blocks you can use in creating these connectors, right? And um, you can see here, this is your, to create a connector to your Amazon Bedrock. You can see Amazon Bedrock connector, embedding the connector to Bedrock Titan embedded model, right? So you specify your region here, you specify your, well, yeah, your access key, secret key, your token, and of course, you specify the Bedrock model in question, right? And your application, your content type here, and then of course, it's going to do the rest for you and create your connector, right? So, with this, let's proceed on the steps we need to take. So, I mean, once you have your connector created, if you're making use of a self-managed open search, right? So that is fine, right? So here, of course, the instructions are very quite direct, right? So for prerequisites, of course, you need to um, when configuring your Amazon setting, only change the values mentioned in this tutorial. Keep all other settings at their default values. So first things first, you need to deploy your DeepSeek R1 to Amazon Bedrock. Um, in this case, to be able to do that, what I did in this case to be able to do that was to follow through with a guideline for that. And of course, I can share with you that guideline, which was something similar to this, right? So, which was something similar to this. In my case, I made use of the DeepSeek R1 um, DI Steel Llama 8B 3 main model, right? So that was what I used. So I created an S3 bucket. So you can see here, I created an S3 bucket in my region, right? And I created a folder in that S3 bucket, and of course, I downloaded the files here. So you can see all of these files. You can either download them from here or or straight from the Hugging Face environment, right? You can do that. And then I imported them into the S3 bucket, right? So generally, what I did from here was I uploaded the files into this place, right? And then I went for this option to import a model, right? So you can see from here, you can follow this step. You go to Amazon Bedrock. Um, so once you upload all the files here, you then go to Amazon Bedrock. I'll just type Bedrock here. You go to Amazon Bedrock here and you choose the option here to import model. So you see under tune, you can see imported models, right? And then you can either, you basically have to click on create import model, you specify the model name, you specify the job, and of course the S3 bucket where you uploaded the model files, right? And then once you're done with that, you can either create a default role or use another role, and then you what, you import, you click on import the model. Now, once you do that, you would see something similar to what we have here, right? And then you can click on the model, and of course, you can open it in Playground and, try to interact with the model. In this case, I can run something like this. We have an example here. So if you look at this, yes, I can do something like this, right? I can just copy this and go to my environment and I paste this. Or write a prompt. Yeah, 1 minute. All right. Okay. So now I can paste this here. Generally, the reason why you have to put this is all stated in here. You can see, um, basically, you have to put all of, you can see, as we are using an imported model in the Playground, we must include the beginner of a sentence and user assistant tags to properly format the context for DeepSeek models, right? These tags help the model understand the structure of the conversation and provide a what, more accurate responses, right? So if you're following the programmatic approach, of course, in the following notebook, then this is being automatically taken care of by what, configuring the model. But because, of course, we are not taking the automatic approach, we are basically running this from, well, the UI. We can, we then need to have that in place. So you can see I can run this, and this is going to start interacting with the model. So it's, well, usually sometimes you would see this error, but not to worry about that. Let's see if we can run this again. This happens some of the time, so not to worry. Single prompt, let me see. I know I did experience this while I was, let's see what is happening here. So it says review this. Of course, it says when you invoke the model for the first time, if you encounter a model not ready exception error as a key, automatically tries to retrieve or retries the request with what, exponential backoff. The restoration time varies depending on the on-demand fleet and model size. So you can customize the retry behavior using this config. For more information, try this. So it's expected that sometimes you will see this error due to the fact that we are trying to invoke, an imported model. So, but let's try again and let's see if the, let's see. All right, this is still happening, but anyway, let's not allow that interrupt us. Some of the times this happens. So yeah, let me see what this is saying one more time. So it says model is not ready, inference, wait and try again, refer to this, of course, which is yeah, what the prompt was already telling us. All right, let's proceed from there. So now we have the model itself in uh, Amazon Bedrock. As you can see under the tools, we have the imported model here, right? So yeah, this was the job that was created while I was importing the model, right? Okay, so the next thing you need to take note of here is you need to create an IAM role for the Bedrock access, right? So this is, like I said, probably very straightforward. It should be very straightforward. In my own case, I was able to create the role as well. So you can see this role already exists in my environment. Um, if you go under IAM roles, or you just can go under roles, right? If you search here, you can see that I already have this role configured, right? And you can see, well, you can see the permissions I have here, the policy which I have, put in here already, right? Um, from here, you can see it says this is the trust policy, and of course, you should add your what your DeepSeek R1 model ARN, which is what you see here, right? This is what you see here. So this is the model ARN. So I already have that role in place, and this is basically giving it what just a read access, right? Now the next thing we need is configure an IAM role for the OpenSearch service itself, right? So you need to configure an IAM role for the OpenSearch service, right? And once you're doing that, for me, in my own case, I already created this IAM role for the OpenSearch service. So you can say this, right? So the first one we created an IAM role to be that helps to be able to invoke this model. Next, we are creating an IAM role that helps to you can see here generate a new IAM role specifically for signing your create connector API requests, right? You can see here, create an IAM role, name this with the following trust policy and permissions, right? You can see this is the trust policy, which would contain your IAM ARN and the what? The assume role, right? And you use your IAM ARM user to assume the role in what? Step 3, right? But then you can see under the permissions is your IAM role ARN created in step 1, which is this role which we created in step 1. And of course, the second one is your open search domain, right? So if you look in here, you can see that in my own environment, I already created the role. In my own environment, I already created the role. So if you go to roles and you click on this, you will see that mine already exists. And of course, we have this, you can see we have this policy. Here is the role which we initially created. And of course, this is our DeepSeek model domain, right? This is our DeepSeek model domain. So you can just click on next, and of course, you know, yeah, save the changes. And then the next thing we need to do in here is once you have this role, the next thing is to map a back end role, right? So there's quite a lot of challenge with this. I think I got quite a lot of challenges with this, but let's try and see um, if you are able to authenticate with this. But this is generally what you need to do here. So you need to log into the open search and select security. So let's go into the open search, right? So yeah, can go here, open search service. So here is the open search service or domain which we created. One thing you can do is, of course, this is the dashboard you need to click on. So you can do this, and then of course it will ask you to log in. Let me see if it accepts my user details. Okay, let me try this. So I still get this right. So the reason why I'm not able to log in is that if you take a look here at the configuration, here is configured with I am, but no specific user is listed here, right? So one thing you can always do to be able to access this is you can edit this, right? And then you can say create a master user, and then you can come here and do your thing, right? And come here and do your thing here. Let me just do this. Now, if you take a note at this, and if you see here, if we go to open search, now one thing you will notice is that in the configuration here, if you click here and you go to the security, you see here it just says master user type is what I am, nothing more. And it says I am identity enabled for API access. For API access, it says no. I am federation options enabled. It says no, right? So you see that all of these are not enabled, right? You can see all of these are not enabled. So what you do is in here, when you are creating that, you can say, yeah, so you can say, Identity Center allows you to connect to existing source and gives AWS application a common view of your users. So you can enable this, right? You can enable this. And although we have domain level access policy, you can see this here, right? What else do we need to configure? Right? You can also enable, yeah, you can enable this if you would choose to, or maybe I don't need this. Let's see. Yeah, this is if you are using JWT. I don't think we need this basically, right? You can see here SML by this. But generally, all I enabled is this, right? You can see username, right? Instead of user ID, you can specify the attribute that contains this. And yeah, you can say group name, right? So existing identity source, blah 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 blah. So you can see Configure different region accounts, connect IAM Identity Center instance from different AWS regional account, provide the region and ARN details. So, well, you can configure that here. You can, for instance, um, can say US East 1, and you can put your ARN here, right? You can decide to put your ARN here. That's if you are, for instance, okay, let me set this here and let me see if this works for us. Just 1 minute. Uh, 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 this. Uh, okay, so this doesn't work for us anyway. But anyway, since I am within the same region, I'm not going across another account, so that is absolutely fine for me. I can as well just copy this guy here and then just have this here. All right, so the next thing we do here is to click on Save Changes. Let me see if I'm getting any pop-ups. Okay, good. Now it's updating my domain. It's updating my domain, right? So it's going to take some, maybe few seconds I get to update the the cluster, to take few seconds to update the cluster. You can see it's modifying, applying changes. Then you will see what then happens when we switch from just the I am to right to when we switch from the I am to a user. So if you look at this, you can see here it says yes, it's enabled. What? But what? You can see internal user database, right? Is enabled, but what? Internal user database. So you can see that in there. So the next thing I need to do, okay, I can see it's still applying the changes, although it says applying changes. Let me see, cluster configuration change in progress. Initializing. All right, so now I'll come here. Since the domain is active, I'll come here where I tried to log in. Where was it that I tried to log in? I think it was here. And I'll refresh, right? And then try to log in with my details. And then let's see, hopefully we are okay. Now you can see that we are able to log in, right? So you can see, of course, the roles, the identities, and all of that. Now, the next thing you need to do, as directed by the document here, is you need to come to security, you go to roles, and then you look for the ML full access. So, in case you're wondering what I'm looking for this here. I think is good. We are looking for the ML full access role, right? So we come here and we search for ML full access role, right? And you can see this, right? So you can see this is the ML full access role. In my own end, I've been able to map a user. You can see is reserved for security plugin environment. Reserved roles are restricted for any permission customization, right? So you can see the cluster permission. But look at mapped users here. Now the role, right, which I created here. If you remember, we created um, the migrate Bedrock DSIP connector role, which is what we found here under roles. Yeah, so you can see the role and you can see the permissions assigned to the role, right? You can see these are the pass role to be able to invoke the model, and I've also given permission to the domain itself, right? Now, this role itself, right? This role itself is what is being attached here as the backend role. Of course, you can say here manage that mapping role. So you can see this is what um, this is what basically we've been able to do, right? By creating this role that gives the user access to be able to connect to this user, right? And of course, we click on map here, which basically grants the ML full access. Now, the next step, which we need to do after doing this, is to create a connector, right? So um, for you to be able to create a connector, what we want to do is for the model, right, to be able to connect, for instance, the model to our open search service, we need to run this, right? So you can see this is a simple code that helps us do something like that, right? To be able to run this, I have created a just a simple um, here. So you can see in my environment here, I logged into my AWS environment, and I was able to fill in all the details, which would require, of course, you need to put in the deep the DeepSeek you need to put in your domain here, the link to your domain. Of course, you can get that from the portal. You need to put in the location and, of course, the service itself, and put in the various roles which we have created, right? And then the next thing you need to do is to run this, right? So to run this, you can say a Python 3, and then you call the file name. For instance, this is connection.py. Okay, so for instance, I'm getting a 401 here, but I would probably take a look into that, but don't allow that to disrupt you, right? So the next thing you need to do once you get the connector ID, it should be something like this, right? The next thing you need to do is you now need to log into your dashboard environment to register the model, right? So you can see open the DevTools console and run the following request. So I can copy this, right? And do something like this. So here we already logged in here, right? So I'll go to home and you will see, yeah, DevTools, right? You can see I posted this already to this, and you can see you can run this. You say, okay, yeah, the name provided already existed with group ID this, right? So I already registered this model already. That's why I'm getting this error. Um, the next thing you need to do is, um, yeah, I've gotten this already, right? So the next thing you need to do, for instance, is this. So assuming I'm going to assume these values here because I got a 401 error, right? And once you've done this, you've registered the model. The next thing you need to do is you need to run this command here. Basically, what you'll be replacing is the model group ID, which is the output of what you got from running this command, plus the connector ID, which you got from here, right? So in this case, it will be something like this. Um, it would be something like this. I remember the value I got from my end at the time was this. So I will just copy this and replace this here and assume the other value. Of course, there's a tendency we might have some errors, but I just want to show you how to actually do this. And then you run. So you say fail to find the connector. Yes. The reason it failed to find the connector is because we were not able to, we were having a 401 error, right? Now, the next thing you need to do here is, of course, you will get a tax ID and a model ID, and then you deploy the model. Once you have deployed the model, you get a response like this. Then you can now test if you can connect from the open search, right? And of course, you can start interacting with the model from there. If you then want to further configure your model, you can do this from here, right? So you can see we are just putting, like, creating like a pipeline to be able to communicate to the model from our open search. You can then as well, of course, create vector databases where you want to, create chunks of your data, right? And populate it in the open search domain. And of course, you can search the indexes. And lastly, here, you should be able to get responses from your chats, right? You should be able to get responses from your chat. So, this is one way you can actually implement your RAG, your retrieval augmented system, making use of your S3 buckets, your what's it called? Yeah, your S3 buckets, your open search service, and of course your Amazon Bedrock where we deploy the model. I don't know if there are any more questions. I know time is far spent. Do we have any questions? Hello, Anne. Do we have
Yeah,
any questions?
I don't see any questions yet.
All right. Okay.
There are no
I think
questions so far.
awesome, awesome. I hope we were able to follow through with the demo, and we were able to understand how to implement a RAG, a retrieval augmented generation system, while making use of your S3 bucket. In this case, we made use of the DeepSeek model, open search connectors or open search service with a domain, and of course the Amazon Bedrock where we hosted the model. So I hope everyone was able to learn 18 or two from this. All right. At this point in time, I think we can proceed then with the quiz, I guess.
Yes, yes. All right. So thank you very much, Mr. Promise, for this very detailed section. I believe that
Well,
we had people that were following, and if you're not able to follow, this video is going to be available, so you're able to come back to it and you're able to follow through. All right. So I think someone is asking the chat if we can get the link doc.
yes, I'm pasting the link to the doc here. I've pasted the link to the
Okay.
front document. Also, to be able to import the model into the Amazon Bedrock from your S3 bucket, I've shared the link on the chat as well. Yes,
Awesome, awesome. All
awesome.
right, so I believe we've gotten that. So right about now, we are going to be going into the session of games. So since you don't have questions for us, we have questions for you, and this will
Exactly.
test that you've actually been following. All right, so I'm going to be sharing in the chat how you can partake in this. So you can join the game at www.kahoot.it, and you can use the pin as well. I'll share my screen right now so we can follow through together and see those that are joining in. All right, so we are waiting for you to join in www.kahoot.it and use the pin in the chat to join in. So who is joining in first? Who is joining in first? So you have the opportunity here to actually win something from the community. So we are waiting on you to join in. I'm sure you don't want to miss this opportunity. All right, so we are waiting. Kahoot.it, and you can use the pin, or you can scan the QR code that you're seeing on the screen. Let's give some time. I believe some people are trying to get game ready. So let's have you join in. Let's have you join in. So we are waiting. Who is joining in? Join in. And this is the 781. It's game has ended. Okay, give me a second. Please try it. Okay, Victor Robin, the Dawn. Okay, who else is joining in? Let's have at least two more persons join in, or this game will be between Victor and the Dawn. All right, so 1 second, 1 second. Let's have you join in. Let's have you join in. Let's have you join in. Okay, so if we don't have any more persons join in, I'm going to go on with Victor and the Dawn. All right, so let's start the game. So Victor and the Dawn, I believe that you're ready. Okay, so let's start this and let's see who wins. 3, 2, 1. All right. So which AWS service provides foundation models for RAG? Which AWS service provides foundation models for? We have one answer so far. Okay. Let's keep it coming. Let's see. Awesome. So we have one answer, one correct answer, which is Lambda. And let's see who got that. Victor Robin. Amazing. All right, let's keep it going. Let's keep it going. Let's see if Victor remains at the top. What is the primary role of OpenSearch in a RAG architecture? What's the primary role of OpenSearch in a RAG architecture? Oh, let's go to the next. So Victor still stays the chat. A RAG pipeline. All right, let's see this is. The person goes, what step happens first? Okay, so I believe we can still see this. Okay, so we have answers and let's see. Awesome, we have the Don topping the chat right now. Okay, so let's see if he stays there. This is the last question. What does Bedrock do after OpenSearch returns relevant documents? What does Bedrock do after OpenSearch returns relevant documents? Let's see who wins this. 3, 2, 1. No answer to this one. Okay, so let's see who is the winner of the AWS 2026 Study Series 14. The second position is Victor Robin, and the first goes to the Dawn. Amazing, amazing, amazing. Congratulations, the Dawn. We are so excited for you, and we are ready to give you our gifts. So just do well to reach out to us via our email. I'm going to be dropping it in the chat. So you can do well to reach out to us via this email to let us know that you're the one that actually won this particular session. All right. So thank you so much, everyone, for participating in today's study series, chapter 14. By next week, we are going to be having another amazing session, and it's going to be running through into August. So please do well to partake in the upcoming sessions, and who knows, you can also stand another chance to win. So again, a big thank you to our speaker, Mr. Promise Uche. We are so grateful for the time we've spent tonight, and this is the
You.
time well spent because we've learned. And just like I said, please, you can always come back to the video to practice. Right, so thank you so much, Mr. Promise. Thank you so much, everyone,
Thank
for joining in.
you.
See
Thank
you
you
again.
all.